Welcome back. Algebra 1 here with us at MPB. So glad you came. We are continuing our working with functions. Today our lesson is adding and subtracting functions. We are looking at APR1. I can add and subtract polynomials written in function notation. Okay, so let's do some review. We've got our calculator and we have our Desmos skills. So let's go ahead and look and see what this review is. If f of x equals 2x squared plus 6x minus 10, what would be the value of f of 4? Now remember, all I'm doing is plugging in that 4 everywhere in that function's equation that I see x. So if we wrote it, it could look like f of 4 equals 2 times 4 squared plus 6 times 4 minus 10. That's a simple calculator skill. Or I could plug it in Desmos. Let's do both and see what we've got. First, we're going to hit the calculator. So I'm going to plug this in as, make sure that we have, yep, okay, making sure I got it right, I'm sorry. Okay, so I have 2 times 4 squared plus 6 times 4 minus 10. Got to make sure that you plug these parentheses incorrect because one little change of the parentheses will change our values. And what do we get as f of 4? We get 46. So we could plug that in our Desmos or we could plug that in our calculator. So now that we've seen the calculator skill, let's go back and see Desmos skill because I want to make sure that everyone is comfortable with both of our tools. So I'm going to put in 2x squared plus 6x minus 10. There's two ways I can do this. I can go over to where my 4 or my x equals 4 and see where it might cross. And it's way up here. Way up here. So I may not have all that time to scroll up and down. So my next tool that I have with this is to pull a table. So I'm going to hit my gear and pull a table. I don't see the 4 in my x value, so I'm simply going to type it in. And there is my 46. Two possible tools that we have, two possible ways that we can find the same value. We've got to make sure that we have all these tools in our toolbox. All right, so let's look back at our slides and see what it says. Okay, so we plugged it in. Now, when you add and subtract functions, you cannot add apples and car parts and get something. It just doesn't work like that. Same thing with our functions. I have to add or subtract like things, or what we call in math, like terms. Coefficients and variables to coefficients and variables, constants to constants, variables to variables, same variables to same variables. So we have to make sure that we are looking for those like terms. So let's look up here and see if we can add these. It says, when you add subtract functions, remember like terms. So let's look at this first one. I have 3x plus 4x. I have a coefficient and a variable, and I have the same variable. So yes, I can add those. Now, you may pick up that calculator and put in 3x plus 4x, and you're going to get this really weird number. Remember, our x is an unknown variable. I can't plug it in the calculator because I don't know what it is. Not yet, anyway. So what I'm going to have to do is keep my x as an unknown variable and add the coefficients. 3 plus 4, obviously, 7x. So yes, I can add that one. Let's look at this one right here. All right, let's look at this one. 3x plus 6. I have a coefficient and a variable, and I have a constant. Ms. Killen, what's a constant? A constant has no variable whatsoever. It's going to be 6 today. It's going to be 6 value 3 weeks on a Thursday at 2 o'clock. It's still going to be 6. So you've got to make sure that it's like terms. So I cannot add this one because I do not have like terms. So let's look at this one. negative 9x plus 6x. Look at your partner at your table and y'all discuss, can I add or subtract these? Or can I add them in this case? That's some good discussion. Now, don't let a negative number fool you. It's just a negative number. It's still a coefficient, and it still has the same variable as that 6x. So yes, I can add those. Now, you may need to plug in your calculator the negative 9 plus 6, and when you do, you get negative 3x. So I can add that one. Let's look at this last addition problem. This one's a little bit different. Look at your table partner and talk about this one. That was some good discussion. I heard we've got the same variable, Ms. Killen, so we're good to go. But we're not. I have my same variable, yes, but x to the third and x to the second. If I have different exponents, I cannot put them together. They're not like terms. So those I cannot put together. That was some good discussion, guys. I'm really enjoying this talking and knowing that we're using this past knowledge to come up with these answers. So now let's look at subtraction. I've got 12x minus 2x, coefficient and variable, same variable, so I can get a 10x here. Let's look at this one. Negative 25x minus 36x, coefficient and variable. Even though one of them is negative, I can still put that together. Now, Ms. Killen, I can't do that in my head. So we pull our calculator. Can't put the x in there, but I can put my coefficients. So I put a negative 25x. Now stop. You cannot use the subtraction sign as your negative. You have to use the negative button, which is under the number 3. Have to put it like that. So negative 25 minus 36, and what does it get you? Negative 61x. Awesome. Let's look at this next one. Can I subtract it? Yes, you can. What I would do, like we learned, when I subtract a negative, it's just like addition. So I put addition right here because the subtraction of negative is just like addition. The subtraction of negative is just like addition. You will hear me say that umpteen million times. The subtraction of a negative is just like addition. So I have the same variable and I have a coefficient. 14 plus 5 would give me 19x. Now what about our last one? Can I subtract that one? You're right, I can't. Because I have a coefficient, a variable, and a constant. So I cannot do that one. That's good. Y'all really got this going. So let's look at our next screen. Let's see what it says. Remember, you can only add like terms. Your plus and minus inside that equation or expression is going to serve as your positive and negative. And then it says line up or indicate like terms, which is a good thing to remember. All right, so let's look at this one over here. It says when you add subtract functions, you must look for like terms and notice the plus or minus inside. All right, so let's look right here. I have g of x and I have h of x. Now it tells me to evaluate. So what I do is I'm going to put my g of x here. And I'm going to add my h of x, which is negative 9x squared minus 3x minus 1. Now, you may be sitting in your chair going, why did you put it one on top of the other? Do y'all remember in elementary school when we learned 1 plus 4 equals 5? Same thing. I have like terms on top of each other. I have my coefficients with my x squared, my coefficients with just my x's, and then my constants. So inside those functions, when I see an addition or subtraction sign, that's going to mean positive or negative. So let's go ahead and put these together. It says 3x squared plus negative 9x squared. All right, I am going to get negative 6x squared. Then I have 2x plus a negative 3x. Negative x. And then I have 5 plus a negative 1. I get a positive 4. And there is our answer. When I put these two together, this is what I get. Awesome, awesome. Let's look at this next one. Now I have my functions g of x and h of x. I want to evaluate the following. I have h of x minus g of x. And then I have g of x minus h of x. Now, up here it says, even when you're only using two different functions, depending on how they're arranged and what type of operation, you'll get different answers. Now, this is where we have to really pay attention. Even though I'm only using two things that I'm subtracting, depending on where I put them in the operation, depends on what type of answer I get. For instance, 1 minus 2 is negative 1. 2 minus 1 is 1. So I have to make sure I'm understanding where I'm putting everything for the different type of operation. So let's go ahead and write these up here. So I'm first using my h minus my g. So let's go ahead and write this out. So I have negative 9x squared minus 3x minus 1, subtraction. Then I have 3x squared plus 2x plus 5. Okay, I'm going to give you a minute. Go ahead and do those coefficients. See what you get. I got that exact same thing. 12x squared minus 5x minus 6. Now, Ms. Killen, I didn't necessarily get that. Go back and look to see what you did with those plus and minus inside the function to make sure that you use it as a positive number or a negative number, and how it worked with subtracting. I always put my subtraction symbol over here to make sure, or my addition symbol, to make sure I know that's the operation I'm doing with the whole function. Let's look at this next one. Go ahead and work it, and let's see what we get. All right, so when I look at this one, I have some where I'm subtracting negative signs. Now, we said last time, when I subtract a negative, it's just like addition. So when I subtract a negative, it's just like addition. We've got to remember that. So 3 minus a negative 9 is going to be a positive 12x. 2 minus a negative 3 is going to be a positive 5. And 5 minus a negative 1 is going to be a positive 6. Ms. Killen, I got the same numbers, but do you? I have 12s, 5s, and 6. But depending on how I put those functions depends on if they were negative or positive. That's what I mean when you've got to make sure that you're understanding when I'm looking at that positive and negative numbers, how it works in those operations. You've got to make sure that you keep those in mind. So the next says, let's do some practice. Okay, so this is where we're going to look to make sure that we are understanding what's going on. It says, use the following functions for the operations. Always work the parentheses first. All right, so f of x is straightforward. That's just a trinomial. G of x, well, I have negative 2 that is being multiplied to everything in that parentheses. So I'm going to distribute to everything in those parentheses. Ms. Killen, why are you drawing the arrows? That helps me remember where I'm multiplying or what I'm multiplying that negative 2 to. So let's see. Negative 2 times 4x is negative 8x. Negative 2 times a positive 5 is negative 10. And then bring down what I didn't use. That's my g of x extended. Now let's look at h of x. Now I have the 6 that I'm going to distribute to everything in those parentheses. Wherein I have 12x squared plus 18. So I want you and your partner to go ahead and I want you to do 1, 2, and 3. Make sure that you are paying attention what operations all 3 of these are asking you to do. Don't just assume. You've got to make sure that you're understanding what function is going where and what operation you're doing it with. So let's go ahead and look at these. All right, Ms. Killen, when I set it up, it didn't look like that because we forgot like terms, adding and subtracting of like terms. I can only put like terms together. So let's see what we've got. 4 minus 12. I get a what? Negative 8x squared. Well, Ms. Killen, I don't have anything with that negative 2x. So I'm going to bring it down. You will also sometimes see people or different equations put a 0 there as a placeholder. And then I'm going to do my negative 3 minus my 18. And what do I get? Negative 21. Look to see how I did it. Look to see the math that I did and see what yours is. And if you got it, great. You may have had to tweak a few things if you didn't do the adding and subtracting right, but make sure that you always, always, always look to see what's being added and what's being subtracted. I'm going to do the same thing with number 2, but I'm just adding. Look at number 3. I am adding all 3 of these together. So let's see what that looks like. F of x, whoops. All right, so I'm doing 4x squared minus 2x minus 3 plus g of x, which is negative 3x squared minus 8x minus 10 plus 12x squared plus 18. Everybody take a minute, work this one. All right, so I have 4 plus a negative 3 plus 12. What did we get? If you plugged it into your calculator, I would put 4 plus negative 3 plus 12. I get 13x squared. I have negative 2 plus a negative 8. I get negative 10x. If you need to and you want to put a 0 there, so it's a placeholder, that is more than okay. Then I go back and I have negative 3 plus negative 10 plus 18. And I get a positive 5. Make sure that yours looks something similar to mine. Now you're probably saying, Ms. Killen, you didn't give us number 2's answer. I didn't. Let's look. I'm going to have 12x squared plus 18 plus, then I'm going to have, I'm going to go ahead and erase this so we can use this part of the board. I'm going to have negative 3x squared minus 8x minus 10. Now you're probably sitting there going, Ms. Killen, why did you write it like that? Because sometimes you'll see it. What I do is I put my like terms. 12x or 12 plus a negative 3, I'm going to get 9x squared. I don't have anything to go with that 8x, and then I'm going to have 18 minus 10, going to give me a positive 8. So now I have all 3 of my answers. Make sure you're paying attention. What am I adding? What am I subtracting? Do I have a positive number? Do I have a negative number? You always want to make sure that you are answering those questions. All right, now it's time for you to master. Let's see what we can do with what we've learned. It says, I have m of x, p of x, and t of x. Consider the functions above. What would be the resulting polynomials when you complete each operation to the right? I'm going to go ahead and tell you now to pause the video, work independent or work with your partner, making sure you are writing all of those answers down so we know exactly what they are. All right, so let's see if I can get the same answer as you did. X squared plus 6x minus 5 minus 3x squared. Oh, hold on. I've got to work this out before I can plug it in. So I have 4x minus 16. So I've got to make sure I am working those parentheses first. So I'm subtracting. Sometimes I put a 1 there just so I have the place value so I know what numbers I'm adding and subtracting. So 1 minus 3 gives me a negative 2x. 6 minus 4 gives me a positive 2x. And negative 5 minus 16, Ms. Killen, I'm having a hard time doing that in my head. That's perfectly fine. Sometimes you want to make sure that you do the math correctly. Negative 5 minus a negative 16, I got a positive 11. So there's my first one. Let's look at the next one. I have 16x squared plus 16x plus 20, and I'm adding x squared plus 6x minus 5, putting my 1 there just for a place value. 16 plus 1 is 17x squared. 16 plus 6 is plus 22x. 20 plus a negative 5 is going to be a positive 15. Awesome. You were doing great. All right, so let's do the bottom ones. I've got 3x squared plus 4x minus 16. Then I have x squared plus 6x minus 5. I am adding these, making sure I'm getting my answers. You can always use that calculator. 3 plus 1 is 4x squared. 4 plus 6 is 10x. Negative 16 plus a negative 5 is going to give me a negative 21. Last one. Let's see if we can get it. So I have m of x. I have negative 16x squared plus 16x plus 20. Then I am subtracting p of x. Subtraction, 3x squared plus 4x minus 16. So I've got negative 16 minus 3. So negative 16 minus 3 is going to be my negative 19x squared. 16 minus 4 is going to be my positive 12x. 20 minus a negative 16 is going to be a positive 36. Check your work, check my work, see if we got the same thing. Making sure that I did my math like you did your math. Awesome. One thing or several things that we don't need to forget when I'm adding polynomials, I have to add and subtract like terms. Always paying attention to those positive and negative signs. I'm taking note of what functions are and where they're being placed and how I am doing operations with them. When I'm subtracting, I'm also subtracting like terms. I'm paying attention to those positive and negatives, making sure I know where they're being placed in those functions. I am so glad you came to work with us today and learn. Thank you for coming and learning with us here at MPB. I'm Ms. Killen.